Hi guys, so we're going to keep on talking about functions right now, but now we're going to take a look at how functions can be represented by equations, which we didn't really show. Remember that graphic organizer we did about ways of representing relations. Okay, we didn't show equations in that graphic organizer, right? We had ordered pairs, we had a table, we had mapping with the bubbles, and we had the graph. But we didn't have equations in the way of representing a relation. Once again, remember, a function is a special type of relation. All functions are relations, but not all relations are functions, okay? And we're going to see why a function can be represented by an equation. So, just filling in the notes page, right? Functions can also be represented by an equation or rule. Why? Because an equation, for example, y equals 2x plus 3. This equation over here, it generates an infinite amount of ordered pairs. What do we do whenever we have an equation? We usually create an xy table and we start plugging things in. We choose the x value and we can choose any x value over here. So for example, I want to choose 1 for x. What happens when x is equal to 1? I plug it in. 1 times 2, 2 plus 3, 5. This means that my y is going to be equal to 5. And this right here is the ordered pair, 1, 5. And I hope you guys can see that I can choose any value for x, but I cannot randomly choose the value for y. The x value is independent, all right? It's the input and it's independent because I can choose anything. However, the y value depends on the x value that I chose. I can't just choose a y value. It has to be related to the x value that I chose. So for example, if I choose x to be equal to 0, x is equal to 0, I'm going to plug it in here. I get 2 times 0 plus 3, which is going to give me 3. So whenever my x is 0, my y is necessarily 3. All right, so what we see here is that every equation, it will generate an infinite amount of ordered pairs by taking an input that results in a specific output. All right, the graph of an equation, therefore, would be the set of all its ordered pairs, which often forms a line or a curve. So if we were to put this in a graph, right, we would get the point 1, 5. So this would be the point 1, 5, for example. Then you get the point 0, 3 over here. And if I get all of the points, I could plug in, for example, 1/2. I can plug in fractions, I can plug in decimals, and start filling every single point, all the ordered pairs that satisfy my equation over here, my rule, my function, all right? So this is a very important idea that an equation, it generates an infinite amount of ordered pairs. And when we graph these infinite ordered pairs, they give us a line or a curve. One way that people commonly represent functions is by thinking of a function as a machine, where you throw in an input, which is always going to be our x value. This machine transforms this x value according to the rule, and it gives you your output or your y value, okay? Once again, this is why we call the x value the independent variable, because you can pick, right? It doesn't matter, it's independent. You can pick whatever value you want to put into your machine, into your function. But the y value is called the dependent variable because it depends on the value of x, all right? The idea of a machine also helps us understand why you can't repeat x values in a function. This is how it works. So let's suppose we have two ordered pairs over here. We have the ordered pair 1, 3, and we have the ordered pair 1, 5. This means that if I get my machine, whenever I throw in a number 1 over here, I'm not really sure if this machine is working properly Because in a machine, every time I throw something in, I have to know what's coming out. I have to know, okay, I want to throw this in because I want to have this result. But if I have, for the same x value, two y values, this means that whenever I throw in a 1, I'm not really sure. Sometimes the machine is going to give me a 3. Sometimes it's going to give me a 5. And this isn't very helpful, right? Because this means that the machine is broken. If you throw in something and sometimes it gives you one output, sometimes it gives you a different output, this is weird, right? You don't want a machine that works like that. That's why a function, you can't repeat the x value, because if you repeat the x value, this means that for every input, for the same input, I don't know which output I'm going to get, all right? So this is one of the ideas behind why you can't repeat the x value in a function. This next part over here, graphing functions by table, I think you guys have been doing this since, I don't know, 7th grade, 8th grade maybe, but it's pretty simple, right? It's simply getting a function, generating sets of ordered pairs, and plotting them in the graph. So for example, in this case, I gave you the x values. So y equals x plus 4 is your function. If you plug in -5 over here, you get -1 for your y, because -5 plus 4, -1. If you plug in -4, -4 plus 4 is 0. If you plug in -2, -2 plus 2, 2. And if you plug in 0, your y value is 4. Then all you really have to do is graph these ordered pairs. -5, 1, 2, 3, 4, 5. -1. -4, 0. -2, 2. And 0, 4. Once again, I think hopefully everybody remembers 8th grade, where this is simply the y-intercept. This is a linear function. This is my y-intercept. And this guy over here has a slope of 1. Another way you could graph it is go up over here to 4 and then go up 1 over 1. But now we're working with functions and seeing how an equation generates a set of ordered pairs. So we generate these set of ordered pairs, plot them in the graph, and draw the line, right? Number 2, I'm just going to do number 2. I'm going to leave the other ones for you guys to practice because you guys should know how to do this by now. Once again, I'm going to plug in -4, 0, 4, 8. And my function is y equals 3/4 of x minus 2. If I plug in -4, I'm going to have 3/4 times a -4. But remember that 3/4 times a -4, -4 is the same thing as -4 over 1. And for multiplication of fractions, I multiply the numerator and multiply the denominator. Or something else that I could do is see that I can simplify numerator with denominator. This would give me -1. So in the end, I would have 3 times -1 divided by 1, which is simply -3. So this would give me -3 minus 2, or -5. Plugging in 0. 0 is always the best thing to plug in, right? Because 3/4 times 0 is simply 0. This whole term disappears. And then I'm going to have 0 minus 2, which is simply -2. Plugging in 4 over here. Once again, I hope, just like we did over here, but this was a -4. Now I'm going to plug in a +4, and the 4's will cancel out. But instead of having -1, there was a positive with a positive. So this is going to give me +1. 3 times +1 divided by 1 would be +3. So this first term becomes a +3. Minus 2 is going to give me 1. If this kind of train of thought was too fast and you didn't really understand what I did, then I suggest you pause the video, go back, watch it again. If you still don't understand, do it on paper the way you would usually do it and see if you get 1 for your y value when you plug in 4. If you still can't understand why, then message me, we need to talk, all right? And finally, number 8, plugging in a number 8 over here. This is going to be a 3/4 times 8 over 1. These cancel out. This is going to give me a 2. 3 times 2 divided by 1 would be 6. 6 minus 2 would give me 4. All I have to do now is plug in the values. So this would give me what? -4, -5, 1, 2, 3, 4, 5 down here. Then 0, -2, 4, let's count 1, 2, 3, 4, up 1, and 8, 4. 8, 4, you guys can see that it doesn't fit my graph, right? Because it doesn't go all the way to 8. However, if I had a bigger scale, I could go all the way to 8 and go up 4. And this would give me my line. Could I find points in between? Yes, I could. Could I plug in, for example, 2 and find my point over here? Yes, I could. The difference is that if I plugged in 2, I would get a fraction for the y value. Let me show you guys this over here. I would probably get a fraction over here for my y value, but that's okay. I could plug in 2 and get that ordered pair that includes a fraction or a decimal. I'm going to leave numbers 3 and 4, 5 and 6 up to you guys because this is something you guys really should know how to do, people, okay? Numbers 7, 8, 9, 10, they're a little bit different because the format of the question is different, but the idea is the same. You guys have to remember what domain is, all right, in order to solve this. So look at the instructions. Given each function and domain, find the range values. First thing you have to remember is that domain are all of the x values, range are all of the y values. So what they're telling you is, I have a function over here, I have an equation, I gave you the domain of the equation, this means I gave you the x values of the equation, find the range, find the y values. Guys, you see this is exactly the same thing. I gave you the x values, I'm asking you to find the y values. So this question, these kinds of questions over here, and this question over here, they are exactly the same thing. The only difference is that the format is different. You have to know that domain is x and range is y. We could even create a table, an xy table, because the domain are the x values. So this would mean that my domain or my x values are 4, 6, and 8. And now all I have to do is plug these values in and find the range, which is my y. So this would mean that if I plug in 4, I get 4 minus 5, negative 1. If I plug in 6, 6 minus 5, positive 1. And 8 minus 5 would give me 3. All done. This means that my range, you have to write out your answer, right? Your range would be negative 1, 1, and 3. All right? Pretty simple, pretty straightforward. Numbers 11, 12, 13, and 14, I'm going to leave it for you guys to do it on your own. And finally for today, we have 2 IXLs. Remember, these are in Algebra 2, all right? And worksheet homework 3, which I really think you guys should do it.